Welcome back, everybody. Today we're going to work on graphing logarithmic functions. In the last section, we talked about how log functions are the inverses or opposites of exponential functions, which means that their graphs are related, just like their equations. Let's say that we would like to graph y equals log base 3 of x. The inverse or opposite of log base 3 is 3 to the x power. So we're going to start with this table. And we're going to plug in 3 to the negative second, which is 1/9. 3 to the negative first, which is a third. 3 to the 0, which is 1. 3 to the first is 3. And 3 squared is 9. We use these sets of ordered pairs to make the ordered pairs that we need to graph log base 3 of x. Because inverses are opposites, and remember we swap the x and y values to find the inverse, we swap our x and y coordinates to find the coordinates we need for our new graph. So rather than negative 2, 1/9, we have 1/9 negative 2, 1/3 negative 1, 1 0, 3 1, 9 2. These are the new points for our log base 3 graph. Log graphs, just like exponential graphs, have asymptotes. The asymptotes of our parent function graphs always start at x is equal to 0. For exponential, it was y. For log graphs, it's x. So x is equal to 0. Then I'm going to plot these points. Negative 2, 1/9, negative 2, 1/3, negative 1, 1 0, 3 1, and 9 2. And here's our graph. Remember that this part of a graph right here is going to come super close to that asymptote, but it's never actually going to hop over that y-axis and move to the other side. Let me erase that part there. All right, vertical asymptote at x is equal to 0. Domain. Our domain and range for our log functions are exactly the opposite of what they were for our exponential functions. Our exponential functions, the domain was always negative infinity to infinity. So for log functions, it's our range that's always going to be negative infinity to infinity. The domain is going to include our asymptote and either a positive or negative infinity. So remember, domain is left to right. So on the left side of my graph, we have the asymptote, which is 0. And then our graph is going this way, greater than 0. So our final answer for our domain is going to be x is greater than 0. Let's highlight end behavior. We will discuss end behavior in class tomorrow for all of our graphs. For right now, we just want to be comfortable with making our XY table, plotting our points, and our asymptote. Okay, this is the general equation of transformations. A is going to be your vertical stretch or shrink. If A is negative, that's an x-axis reflection. Inside the parentheses with x is your left or right. And remember, it's going to be the opposite of what it says because x's are liars. And then at the end is up or down. Your asymptote is always going to be whatever your left or right transformation is. If you have no left or right transformation, then remember it always starts at x is equal to 0. All right, our first graph. Log base 3 of x is equal to, log base 3 of x minus 2. This transformation, because it's not in a parenthesis, is down 2. So it's the only thing that's happening to our graph. Our base is 3. So we start with 3 to the x. And I'm going to use negative 1, 0, and 1. 3 to the negative first is a third. 3 to the 0 is 1. 3 to the first is 3. Those are the ordered pairs that I'm going to use to find the ordered pairs for our parent log function, log base 3 of x. Remember, each one trades places. They don't change signs or anything like that. They're just going to trade places. Because we went down 2, our asymptote does not change. Our asymptote only changes when we go left or right. So our asymptote is still here at x is equal to 0. And I'm going to plot these points. 1/3 negative 1, 1, 0, 3, 1. Our transformation is down 2, so I'm going to take each of those down 2. And then this red is my graph. For right now, we're not going to worry about the x-intercepts. Y-intercepts. Our exponential graphs did not have an x-intercept unless our graph went down. For log graphs, we are not going to have a y-intercept unless the graph moves left. So right now we can't even touch our y-axis because that's where our asymptote is. So we're going to put none. Domain, x is greater than 0, our asymptote is 0, and our graph is going to the right, which is positive, so it's bigger than 0. And then our range negative infinity, y, positive infinity. And again, leave some space for end behavior. We'll talk about end behavior in class. Example B. We have a vertical stretch, left 2, up 4. Well, I have an issue though because there's no base listed right here. What do we talk about that a base always is if it's not listed? And that is, it's a base 10. So we're going to start with 10 to the x. Negative 1, 0, and 1. So that's 1/10, 1, and 10. Our log base 10, 1/10, 1, 0, 10, 1. The other thing that I'm going to do on my table is remember our transformations. We work from left to right. Our first transformation is a vertical stretch of 2, which means that we're multiplying all of our y column by 2. Negative 1 times 2 is negative 2. 0 times 2 is 0. And 1 times 2 is 2. I'm also going to go ahead and draw in my asymptote. If our graph went left 2, so did our asymptote, which means our asymptote now is that x is equal to negative 2. So I'm going to take each of these points and move them left 2, up 4. So I start with 1/10, negative 2, and I am left 2, up 4, right there. 1, 0, left 2, up 4, and then 10, 2, left 2, up 4. That makes our graph look like this. So again, we will have an x-intercept. We'll talk about this in class. We will have a y-intercept this time because we moved to the left, and we'll talk about finding that in class. Our domain, the left side of our graph, is at negative 2. That's where our asymptote is. And so we just have to decide our graph is going to the right. Are those numbers greater than negative 2 or less than negative 2? And the answer to that is greater. And then again, our range is always negative infinity to infinity. We're just replacing the x with y because it's range. Your assignment for next class. First hour, you're doing example B on practice your own page. Second hour, you're doing C on the practice your own section. Fifth hour, you are doing A on the practice your own section. And sixth hour, you are doing D on the practice your own section. Have a great night. We'll see you next class.